Hello everyone, I hope you all are doing good. Today I am back with video 2 magnetic effects of electric current from class 10 standard science. If you are not watched the part 1 video of this chapter, go back and watch the video. The link is there in description box. Alright, in this video I am mainly focusing on two important things. One is called magnetic force. Second one is domestic electric circuit. Alright, so let's get into the topic. Come with me. Yes, so see the topic magnetic force. To discuss this, let me consider two magnets. One is here, north to south, and another one is here, south to north. That's fine. Now, can you tell me how do we mark the direction of magnetic field outside the magnet? North to south, right? North to south. So over here, north to south, like this, north to south, magnetic field. If there are two magnets, then magnetic field lines pattern will be like this. Now, I'm going to keep here the current carrying wire, whose name is AB, in which it carries I current. Now it is experimentally proved that the wire will experience a force from this magnet. That means the magnetic field of the bar magnet or magnet will either attract or repel the wire, which is called it as magnetic force. The force with which magnetic field exerting on the wire is called it as magnetic force. Now we want to look here, what are the factors on which magnetic force depends? The factors on which magnetic force depends. I am writing here, factors which depends, magnetic force. I am writing shortly, magnetic force. Number one factor, it is found that is magnetic field. It is generally denoted by letter B. Keep in your mind that too. Yeah, it is found again experimentally. More is the magnetic field, then more will be the force. That is, if you are using here very strong magnet, then more will be the force on current carrying wire. If I use weak magnet, then lesser is the force. So force depends on magnetic field. How they depends? Directly proportional. More is the magnetic field, more is the force. And the second factor experimentally found that is current. Again, current and force are directly proportional, which means more is the current in the wire, then more will be the force from the magnet. Lesser is the current, lesser force only. So force and current are directly related. And the third and most important factor is angle between conductor and magnetic field. This is also an experimental observations. I will tell you what it means. Yeah, listen carefully. Here, if you are keeping, what's the meaning of angle between the current carrying conductor and magnetic field means? You can see here, this angle between conductor and magnetic field. The black one is the magnetic field, white one is the conductor, right? Current carrying conductor. So this angle, how much is in this case? In this case is 90 degree. It is found that when the angle is 90 degree, means conductor and magnetic field are perpendicular, then more will be the force on the wire. Magnet will, kill that wire if it is perpendicular. Keep in your mind. If wire is perpendicular, magnet will, kill the wire. Maximum force, wire will experience. And suppose you keeps on changing. Imagine it's a conductor, okay? It is in the magnetic field. If I keeps on changing the angle, then force will reduce. And eventually, when the angle becomes 0, that means it is parallel to the magnetic field, then there is no force. then there is no force. Okay, so that's actually the experimental observation. Keep in your mind, when the angle is represented by theta, when it is 90 degree, means like this, then we can say the force will be maximum. In future classes, you will learn the formulas and all, but in the CBSE class 10 standard scope, we can ignore that. Only it is enough, like a theta 90 degree, force is maximum. Fine. When the angle is 0 degree or 180 degree, then we can say force is minimum and the value comes 0. Minimum force will be, that is 0 value. That is angle 0 means what? Imagine this is the magnetic field and this is the conductor. My hand is the conductor for the time being, and this is what angle is 90 degree. Yeah, this is what we called 0 degree, or you can visualize like this once again. This is the magnetic field and this is the conductor. Right now this is conductor, this is the magnetic field, and how much is the angle? 90 degree. Then conductor will experience what? Maximum force. If I reduce the angle into 0, then no force on the conductor. If I just keeping like opposite, that's what 180 meaning. 180 means, look at this. Magnetic field is in this direction. Okay, magnetic field is, don't worry, magnetic field is in that direction, and the conductor is, current in conductor like parallel. Okay, then what will be the force? 0. Another case were like this. Magnetic field is to the right side and conductor is parallel, okay, but current is opposite in direction. So this is what we call the angle 0. This is what we call the angle 180 degree. Opposite, then what's angle? Two opposite end of the protractor, what's angle? Look at this angle, how much it is? 180 degree. So both case will say it is force is 0. I hope you got it. So long story short, what are the magnetic force on a current carrying conductor depends? Number 1, magnetic field, which are directly proportional. Number 2, current in the wire, which also directly proportional. And third one is angle. So when angle is 0, force is 0, and or 180 also. And when angle 90, force become maximum. And one more point, what's the meaning of angle 0 and 180 meaning? Current and magnetic field are, both of them are in parallel and same direction. And 180 degree means parallel but opposite directions. Both cases, magnetic force will be 0. Alright, now we want to look one more thing. How do we find the direction of magnetic force? How do we find the direction of magnetic force? Imagine like, a kid. You can think yourself. If you are standing near with your mom, after getting, science mark list, you are going to your mom and showing like, Mom, look at this. This is a mark which I scored. Then what your mom will say? Sometimes she will hug you and giving congratulations. And sometimes what happen? Hey man, what you're doing this? Why you are spending a lot of money in educations? I can spend that money in something else and all. Mom is like shouting. So sometimes your mom will repels you when she see your paper. Sometimes she start attract you if you see the paper. What decides that attraction and repulsion? Your score, definitely, right? So similarly, magnet also sometimes what happen, this conductor is like a baby. So magnet will sometimes, it attracts the wire or it repel the wire, depending upon the directions of the conductor. I mean the current, depending upon the directions of current or direction of magnetic field. If current and magnetic field are in one particular direction, then force will be towards one end. If current and magnetic field are opposite or somewhat any other direction, then force gonna be another direction. So, Rafi sir, then how do we figure out the direction of force? We have a simple rule is there for finding the direction of magnetic force. Come on, say that rule. Hopefully you know that rule. That rule is called what? Fleming's left hand rule. All right, let's see the Fleming's left hand rule. Definition is important because they ask the questions in exam like explain Fleming's left hand rule. What's the use of Fleming's left hand rule? Use it to find the direction of magnetic force, right? So this is the Fleming's left hand rule statement. I think it's a self-explanatory, right? Because all the figure, everything is here. Now, yeah, can I skip this? No, I'll just give a small hint. So take the left hand. How do we explain how do we apply the Fleming's left hand rule? We want to bring our left hand and keep it like these three fingers mutually perpendicular. Look at this. This is perpendicular to this one, this is perpendicular to each other, and this also perpendicular to each other. All of them are perpendicular, right? Yes. Now see, here according to Fleming's left hand rule, this is the force direction. Thumb should be indicated by force direction, and this for what? Magnetic field, and this for what? Current direction, right? Keep this finger along the current, keep this finger along the magnetic field, then this thumb will gives you direction of magnetic force, right? So I hope you're remembering like this: father, mother, child, right? Father first letter is F, F for force. Mother first letter is what? M, M for magnetic field, and child first letter is C, C for current. You remember, right? That way, FMC or something like that, you can imagine. All right, so hopefully you're expert in this rule. So let me do some couple of numericals based on this. Okay, so come on. I'm discussing the first question here. See the first question. Read the question, then it's a greater idea to pause the video and try to do yourself. Then check the answer from me. All right? Yeah. A proton is moving towards east and uniform magnetic field, which enters a uniform magnetic field directed towards, something is missing here, sorry. So it is actually directed towards, one point is missing here, north. Magnetic field is towards the north. Then find the direction of magnetic force acting on it. So to solve this question, there are directions and all. So let me fix the direction, okay? So here it is the direction. This is what I call it as north. And here it is, south. And this way is basically east direction. And this way basically west direction. So this is north, this is south, this is east direction, this one is, this direction is basically west. And if it is like this way, I will say it's out of the screen or out of the page. If the direction is like this way, it is, I will say it is into the page or into the screen. All right, so hopefully it is fine. Now look, a proton is moving towards east. Proton is what type of charge? Proton is a positive charge, right? Positive charge and current direction are same. So proton is moving east direction. So therefore, it creates a current in east direction. Proton and current direction are same. So proton is moving east direction means current is also in east direction. Agreed, right? Yes. Now, what is the direction of magnetic field? Magnetic field is towards north. Magnetic field is towards north. Then what will be the direction of force? How do we do this? Take the Fleming's left hand rule. No, our left hand. Okay. Then this finger for what? Magnetic field. So I'm going to keep here the magnetic field is towards north. So this is a magnetic field. Then stretch all other finger like this. And is that correct? No. This finger for current, right? Current is in that directions. So I'm going to rotate this one and make it along the current. Okay, it comes this way. Let me confirm once again. This is a magnetic field. Magnetic field is up here, north side. And this for current is towards east. Yes, it's perfect, right? Yeah. Then where it is a thumb pointing, thumb is pointing, see this one, it's like this way, out of the screen, which means out of the page. So force will act out of the page, out of the page. I hope you got this idea. Clear, right? Out of the page. That's fine? Yeah. And now here we have another question. See this one. An alpha particles moves in a uniform magnetic field as shown in the figure. What will be the direction of force on alpha? It's a very famous question, okay? This pattern. And alpha is what type of charge? Alpha is a positive charge. Keep in your mind. So positive charge and direction of current are same. If alpha is going up, current is also going up, right? Then what's the magnetic field here? Towards right side. How do we find the magnetic force? Again brings your left hand. So this finger for what? Magnetic field. So align this finger along the magnetic field. That's step number 1. Then stretch all other 2 fingers. All right. Then we want to align this along current. Over here the current is up. So I am going to rotate this finger to up like this. Wow, now it is correct, right? Perfect, right? So the magnetic field is along right side, current is up. Yes, it's perfect. Now, which direction my thumb is pointing? Thumb gives the magnetic force. Which direction thumb is pointing now? Thumb is pointing into the screen, which means in your paper, if you do this, into the page. So answer is into the page. So like this, we have a similar questions more. So try to practice this one. There are several cases like this. Just practice this one, then you will be expert in Fleming's left hand rule. Okay, I will do some of the questions, then something I am given to you like for your practice and find out your answers. All right? Yeah. The first one. Look at the figure A. What is the magnetic force on the first case? Okay, here I would like to teach one thing to you. Wherever you see this one, a dot, that's very standard. It's indicating out of the page. It is a standard representation of a direction is indicated by out of the page. Instead of writing out of the page, if some physics point, it is written like, marked like a dot, you just decode, that means out of the page. Then anywhere you see like it is presented like a cross, meaning that direction, it's actually indicating into the page, which means what? Into the page. So instead of writing this long word into the page, in physics, you just put a cross mark. Both are same meaning. Got the idea? Yes. Then come back over here. So what is one? Dot means magnetic field. So here's a magnetic field, okay? So magnetic field, that is missing. Magnetic field is like a dot, which means out of the page. And here current is, down. What will be the force? Arrange your finger along the current and magnetic field in this question. Come on, this finger for what? Magnetic field. Which direction is the magnetic field here? Magnetic field is outward, out of the screen like this, out of the page, okay? And this finger for out of the page means like this, okay? Out of the page. And if I stretch the all other finger, it will be like this. And over here, current is down. Yes, this finger is down, correct only. Look at this. This current is down. Current is down. Magnetic field is out of the screen. Perfect, right? Yeah, then where is my thumb is pointing? Thumb gives the force. Where thumb is pointing? Towards left side. Towards the left side. Okay, so the first case, I will write the answer. It is left side. The force is towards left side. Are you okay? Magnetic force is left side. And what about here? Can you try to do this? Yeah, here magnetic field is, it's easy, right? Yeah, magnetic field is to the right side and stretch all other fingers. This finger for current. So turn that finger and keep it along the current. Now it is perfect? Yes. Now where the thumb is pointing? Into the page. So force is into the page. Into the page. Hopefully that's fine. And you just try this one, okay? Self-free try. That third one. What about this one? I'm doing this one also for you. The D. The figure D, what will be the magnetic force direction? You are struggling, right? There is no force in figure D. Why? Why there is no force in figure D? Come on. Because conductor and magnetic field are parallel. When current is parallel, no force, no direction. No force, no direction. So force is 0, so you don't want to, complicate it with your hand. The force is 0, so therefore there is no direction exists here. Try to figure out all other 3 cases. All right. Now, we covered the magnetic force topic. Now here comes the last and important topic, which is called as domestic electric circuit. Wow, the circuit feeling you like little complicated, right? Yes. Anyway, pause the video, then try to look this one for a 20 seconds. Just aware what are the elements present on the circuit, like one by one. Like live wire, neutral wire, electricity board fuse, electricity meter, distribution box, and electric socket, 220 volt, and this kind of things. Just to look, then I will explain to you one by one. Okay, fine. Yes. And my first question to you: how we will connect the devices in our home? I mean, parallel connection or series connection? Answer is parallel connection, right? We will prefer what? Parallel connection for devices in our home. Why? Hopefully you know the reason. If you don't know the reason, go back and check the electricity lesson. All right. Now see, I will start from here. I will start, current is actually coming from this end to there, but for explanation easiness, I will start from that end. That is little more easiness. Okay, come on. Here we have, what you are seeing this, here we have an electric socket. These are the 3 electric socket which I drawn. So what do you call this totally? Schematic diagram of domestic electric circuit. Fine. Now you can see electric socket, how they are arranged parallelly. Fine, that's correct. Observe well, okay, parallelly arranged. And in electric socket, there are mainly 3 holes are there. One we call it as, one hole is connected to neutral wire, other one is connected to another wire which is called it as live wire or phase wire or hot wire. Yes, why the naming is like that? The live wire means, the wire in which current is entering from, outside to our home. Okay, so it has current, right? So it is more dangerous if you touch on that wire directly. That's why it's marked like red in color. Okay, it's also called what? Hot wire, phase wire. And for completing the circuit, current is entering to the device, the wire is called what? Live wire. Returning back, that wire is what we call it as. Returning back from the device, that wire we call it as what? Neutral wire. That's fine. So which is usually in black in color. So now you got right, the 2 holes, what are the wire connected? Live wire and neutral wire. And the third hole, which is like slightly bigger hole, that is attached to one wire is called what? Earth wire. That is for ensuring the safety from electric shock. I will tell you that, wait. So you understood, right? There are 3 wires are mainly. So let me write the observations. The point to be remember, we have a 3 wires mainly, right? 3 wires. What are them? 3 wires. Live wire, neutral wire and earth wire. Okay, you can make a detailed short note. I am just giving an hint here. Fine. And out of this, earth wire is for what? Safety wire. Earth wire is, I will discuss in detail the earth wire soon, just wait. Earth wire is for what? Safety from electric shock. That's fine. Now see again. Now if you look, you might be feeling like, what is happening here, right? What is that, this kind of symbol meaning? It's actually crossing the live wire and earth wire without joining, right? So it's like just an indication where they are independent wires. Okay, fine. Yes. So another important point to be remembered here, the voltage difference between, potential difference between the live wire and neutral wire in India, it is 220 volt. So that's also an important information. The value in India, the voltage between live wire and neutral wire is 220 volt. Keep that value in your mind. That's fine. Then from the devices, we connecting, the devices to our distribution box. The word, it tells you like what it means, right? Distribution box. Yeah. So let me say the plan of your home. Like you are generally entering to your home is like what way? To the sit out or some living room. Then you will enter to a dining hall. From the dining hall, you will go like, to the kitchen for heating food or something, or making food or something. Then you can go for the rest, you have some bedroom will be there. So from the dining, everyone will deviate, right? You will go to the wherever you require. So similarly, from the distribution box, we'll take the electricity to all the devices. So sometimes we want to work like electricity in our kitchen, we want to work in the second floor, some bedroom. So every electricity connection, which is starting from one point, that is called as what? Distribution box. In shortly, it is called DB. I hope you hear the word. Okay, if you're not here till now, then you will start here tomorrow onwards. We will strike this point. DB means what? People are usually using that distribution box. Okay, fine. And before the distribution box, what we have? Electricity meter. Obviously, what is the reason? What is the use of electricity meter? You know the idea, right? What's the electricity meter? It is used for. It's a device used to prepare the electricity bill. Okay, electricity bill, like how much electricity consumed by this household. When you're operating these many devices for this particular hours for a 1 month, how much cost or how much electricity you are consuming. That's actually recorded in your electricity meter. Accordingly, you want to pay the bill in authority, right? So that's what electricity meter. Okay, this is just a schematic diagram. The correct picture is like this. Okay, this is what the distribution box, or shortly DB. Now I hope you got, oh sir, this is what we call DB, right? Okay, this is what we call it as DB. So I am not entertaining you, have to open this DB and all to study. So just, practice, the theoretical learning is enough, because it's very careful we are dealing with electricity. Yeah, come on. And this one is what we called electricity meter, for measuring what? Like electricity, for making electricity bill. And what's the unit of electricity energy meter? That is kilowatt hour. Okay, use commercial unit of energy is what? Kilowatt hour. Hopefully you know that. Then come back. And what we have, another and most important one for ensuring the safety, that is we have another thing is called what? Electricity fuse. Fuse will be there. Fuse is again for what? Protection, right? Or safety measure. Okay, fine. So these are the major things which is present in our domestic electric circuit. So you want to close the book, then try to figure out this entire figure, try to figure out yourself. Then only you will ensure like you are learned or not. Are you able to label all the points like a detailed diagram? You just check it. Okay, every term, don't miss it, any of the term, and follow like exactly the schematic symbol for DB and electricity meter. This is like an NCERT textbook picture. You want to follow this. All right. So then why we need electricity fuse? We want to discuss more about electricity fuse, okay, and more about earth wire in detail. I will tell you that. So what is electricity fuse? Like for what? Safety purpose. Electricity is compulsory in our life, right? It is, we cannot avoid electricity. Okay, every day we record what? Electricity. We all are working, electricity. If electricity is not there, we cannot imagine that world. And one more thing, another half will be what? It is a more dangerous thing. It can cause, like it can kill you, right? It can kill you. And, it's more dangerous things. So means we need the use of electricity, and we want a protection from electricity also. So how do we ensure the protection? By means of electricity, board fuse, or like earthing wire, etc. Okay, we can discuss in detail. And so what are the situation in which why we need electricity fuse? Electricity fuse, in our circuit, sometimes, current exceed beyond the limit. Current exceed beyond the limit due to some mistakes happen in the circuit. Okay, generally current exceed in the circuit is like a two-way. One is called it as short circuit, and other one is called it as overloading. Both problems create what? A fire in the circuit. Whenever a fire comes in the circuit, then our entire home become collapsed or damaged. It kills you, your entire family. Okay, it's more dangerous. So how do we get a protection from that huge fire, electric fire? Use electricity fuse. Okay, so let me say one by one point. The problems in our normal circuit is two things. One is called what? Short circuit. Other one is called what? Overloading. So what do you mean by short circuit? I think this picture tells you clearly, right? What is short circuit and what is overloading? Yeah, short circuit means, look at the simplest example. Let me take a simplest example to you. Here it is a live wire, other one is what? Neutral wire. Sometimes, you can see the insulation of the wire is broken. You can see here, insulation of the wire is broken. Live wire and neutral wire is broken. Okay, then what will happen? Will the current will flow, what do you think? Will the current flow like this way through the circuit? What do you think? No, current never goes that way. If there is a faulty or mistakes comes over here, current will prefer, if that kind of touching comes, live and neutral wire come in contact, current will, go through this path, return back to the cell like this. Current never prefer the earlier paths. If the live wire and neutral wire come in contact, current will go this path. Okay, Rafi sir, then how it is creating fire? Look now, if suppose current is going through this path, do you see any resistance in this path? No, resistance is nearly zero. Okay, when resistance is nearly zero, then can you think what is the current? When resistance is nearly zero, what will be the current? When denominator is very, very less, extremely less, what will be the current? Extremely high. So it is too large, current will comes. And large current can makes what? More heat. Large heat will comes. And the huge heat in turn create fire. This is what we called short circuit. So how do we write in exam? I will show. I hope you understood this. Whenever live wire and neutral wire come in contact, resistance of circuit become what? Nearly zero. Resistance zero, current become infinity. High current, high amount of heat will comes in the wire. Large heat comes in the wire. Wire cannot withstand. Wire will say, I can't tolerate this heat. That heat in turn create what? Fire. From that fire, it's make entire homes like collapsed, and the people around is also become what? Dead. This is what we call the short circuit. Okay, how do we present this one in exam and all? I will tell you. And what do you mean by overloading? Next one, overloading. Overloading is easy, right? The word itself telling you what is overloading. It is overloaded. Okay, fine, I will tell. See, overloading means for a device, if you take a device or any electric socket, take the electric socket, an example of electric socket. Let me take an example of electric socket. Like two small holes, other one is big hole. And backside of it, what is present? The wiring. Okay, live wire and neutral wire. Live wire and neutral wire. Let's say its capacity is like 5 ampere. What's the capacity? 5 ampere rated wire. Which means what? If current exceeds 5 ampere, then that excessive heat creates what? Fire. Okay. So suppose you are connecting the electric socket, many devices. Okay. Like as you shown in the figure, many devices if you connect in electric socket, then what happen? The all devices will take current from the electric circuit. Okay, too many devices if you connect in like a small socket, what happen? It will draw more current. So all devices will collect more current. How much is the capacity of that wire? 5 ampere only. But if you connect more wire here, more device here, it may takes what? Suppose 10 ampere currents. All devices takes what? 10 ampere currents. Okay, this wire will say, I will try to give the 10 ampere to you. But what's the capacity of this wire? 5 only. Automatically what happen? It start fire. Okay, the wire is trying to give like pushing like 10 ampere. what happened? Unfortunately, the wire can't give because capacity is only 5 ampere. So as a result, what you can see, a fire will create. You can see the fire in the circuit. So ensure you don't connect many devices in one single socket. Okay, keep in your mind that point. So these are the two problems leads to the fire. To avoid this one, so both situation you can see what current in the wire is exceeding the beyond the limit, right? So that's why we attaching here an electric fuse. Whenever that short circuit or overloading happen on this part, whenever that kind of short circuit or overloading happened in this region, then if you connect electric fuse, what will happen? Yeah, suppose this electric fuse is like a 15 ampere electric fuse, just assume. Then what will happen? Yeah, up to 15 ampere it will allow. Whenever any short circuit or fault happen, overloading takes place inside, then that demands what? More current. When more current passing time, the fuse wire will melt. The fuse wire will melt. So that current, the circuit become broken. Hence that current won't reaches there, won't create any fire. We will be happy. Okay? If you are demanding here overloading or short circuit create what? It require 50 ampere current. So 50 ampere current want to come from this end, right? So you want to ask to the fuse, give me like allow like a 50 ampere current, but fuse will say I never allow that much current because my limit is this. Okay, so whenever that huge current comes, fuse wire will melt, hence that current won't reaches here. Hence the circuit is broken, all thing is protected. So this is what the fuse working. Hopefully you got it. So the fuse wire have like some properties needed for like keeping the safety. That properties like it should be have low melting point, right? Low melting point. Keep in your mind. Then only it can melt very quickly. Okay, low melting point, and it should be high resistance also. The fuse wire should be high resistance too. Okay, because that want to heat it up before heating all other devices. Okay, so this is the complete point which you record, remember, in domestic electric circuit. And I think I didn't mention about earth wire, right? What's the use of the earth wire? Whenever there is a device, okay, some excess current comes in the device. The leakage, current leakage takes place and come in the surface of the devices. Then what happen? If you touch that device, we will feel what? Electric shock. Okay, we'll feel electric shock. So that's also dangerous, right? So if you connected earth wire to the device properly, then all the leaked electric current go to the earth. Okay, if a device is properly earthed, then we don't feel like any electric shock from that device. Because before reaching our body, the device will took the excess leakage current to the earth directly if there is earth wire is connected. Okay, so that's the purpose of earth wire. We can look in detail. Now let's look how do we present this one for the examinations correctly. So this is a definition of short circuit and overloading. Just to follow this one. Okay, just to follow this one, what is short circuit and overloading? Short circuit and this is overloading. You can follow these definitions and for the examination perspective. Live wire and neutral wire come in contact. Due to that, what happened? Large amount of current flow in the circuit. And what is overloading? If total current drawn by the appliances connected exceed the safety limit, the wire, it gets overheated. These are the problems in our electric circuit. And I told regarding the electric fuse, can we ask a question like this? Name the device used to protect electric circuit from overloading and short circuit. What's the device? Called electric fuse. Here it is a various types of electric fuse having rated like 10 ampere, 5 ampere, etc. So what's the device? Device is electric fuse. Keep in your mind this. And here comes another question like what is the function of earth wire? Okay, what's the function of earth wire? Why it is necessary in metallic appliances? Just to remember this information too. All right, now we have to look just two important questions in this lesson. Okay, last two important small questions. Just read this one and try to solve yourself first of all if you know this. Okay, anyway, I will discuss this one here. What will be the fuse rating is required, right? The question is that way. So what is given here? Power is 1 kilowatt. Will you continue with the watt? 1 kilowatt? No. You record to convert into watt. 1 kilowatt is 1000 watt. Then what's the voltage here? Voltage is also given 220 volt. And what we record? We want to find the fuse rating. How will you decide the fuse rating? First you should want to find how much current that device needs. Okay, how much current this device needs? How will you calculate? How will you calculate current from power and voltage? Yeah, you know P is equal to what? V into I. So I is equal to what? P by V. P by V. What's the P value here in watt? 1000 watt. And what is the voltage? 220. 0 got cancel. 100 by 22 will comes. If you again solve this, you will get 50 by 11, right? 50 by 11. If you solve this one, 50 by 11, 11 fours are 44. It's somewhat like, you know, 4.5 ampere. You can check it out, okay? I'm just doing exact calculation, not exactly calculation, somewhat closer answer just to ensure you got the same answer. 4.5 ampere is the current record for this electric kettle. So what fuse is needed? We want to need just slightly higher than the current requirement. So it is 4.5. So we record what? 5 ampere fuse. So we can select 5 ampere fuse. Okay, 5 ampere fuse for this purpose. Okay, fine. Now see, here it is, you know, an alternative way the same question can be asked. Another pattern. You can read this question. What will happen if you attach this fuse in this for this device? That's actually the question. Value can be changed. Okay, if it is comes in exams, you know, they changes the value and gives to you. So how do we solve this one? Again, determine the current passing through the device. Okay, how will you find the current passing through the device? When power and voltage is given, I is equal to P by V. P is here 1.5 kilowatt. So convert 1000 upon 230. 0 got cancel. When you multiply this one, we'll get what? 150, right? 150 by 23. How much it comes? It comes nearly 6.5, right? 6.5, check it out. 6.5 ampere. So what's the device consuming current? 6.5 ampere. Electric heater is consuming power is what? 6.5 ampere. What fuse you attached? 5 ampere. It is like this way. Imagine there is an electric socket and here our device, okay? Device is what we call the electric heater. And when you connect this one, how much current is taking? How much current it is taking? It is taking current is like around 6.5 ampere. And backside you can imagine like what? It is a 5 ampere rated circuit. 5 ampere rated circuit. So the current coming to the device is like the device is actually withdrawing current is beyond the capacity of this fuse. Beyond the capacity of the fuse, right? So automatically what happened? The fuse will melt. The heater won't work in the circuit. Fuse will melt. This is called overloading. One good example of overloading. You are taking the current beyond the capacity of the ratings of this wires or the fuse. So this is called overloading. Our electric heater won't function in the circuit. That's actually the conclusion. Okay, you got it right. That's wind up our entire chapter discussion of magnetic effects of electric current here. And if you feel like any difficulty to recall any of this topic, no worries at all. Go back and check the video and practice it again. Okay. All the best for your examinations. Thank you so much, Rafi sir, physics teacher, Excel Education Center.